In section 2.4, we look at infinite limits, both approaching infinity for the x and the y. The graph that the book chose to begin with is that of 1 over x squared. So we'll look at what happens as x approaches. We can look at it from as x approaches 0 from the left and the right. So here we are approaching from the right, here we are approaching from the left. So let's look at the limit as x approaches 0, say from the left, of this f of x, which is 1 over x squared. First up, I'm going to take my left hand and I'm going to move along this function, and I see that what happens is the function gets larger and larger without bound, meaning that the function approaches infinity. I'm going to look at this function as limit as x approaches 0 from the right. I'm going to pick up my right hand and I'm going to go towards 0, and I see that in this direction I'm also shooting up to infinity. We can also look at this function as x approaches infinity. So as x approaches infinity of this f of x, as my x's get larger and larger, this function is headed towards, and you'll notice this is verified on the tables as well, x is headed towards infinity, y goes to 0. We also will look at it in the other direction. Limit as x approaches negative infinity of this f of x. So as x goes towards negative infinity, this function is also going to 0. So I have looked at limits where the y values are going to infinity, and then I'm also looking at limits in which my x values go to infinity. And you might recall that this x equals 0 line is a vertical isotope, and we'll define vertical isotope in this section to be one in which the left and the right hand limits are approaching infinity in one direction or the other. Here we have the formal definition of an infinite limit, where x is approaching some value and the f of x is growing arbitrarily large as x gets closer to that value a. Let's look at this example 1. They want us first to look at the limit as x goes to 1 of this function f of x, and I could write the function there, but I'm lazy. So as x goes to 1, I need to look at this both on the left and the right. So as x approaches 1 from the right, I'm going to infinity, and as x approaches 1 from the left, I'm going to infinity. So I can say that this limit exists, and it is indeed infinity. However, if one of these had been going up to positive infinity and the other had been going down to negative infinity, I would have to say that that limit fails to exist. Remember that the left and right limits have to be equal in order for that limit to exist. Next, we'll look at this limit as x goes to negative 1 of f of x. So I'll look at both the left and the right limit. The limit from the right is negative infinity. The limit from the left is negative infinity. This limit exists. Here we have the formal definition of a one-sided limit that I spoke about in the previous little section. On this one-sided limit, I'm looking at the limit of my function, in this case a. I'm looking at the limit of my function as x approaches a from the right. This indeed goes up to positive infinity. Looking for my next case, limit of this function as x approaches a from the right again. This one would be negative infinity, and they're just showing you the different cases here. Here we have the formal definition of a vertical isotope. A vertical isotope, we have, if I have a limit that exists, that means that the left and the right limits, if they're going to positive or negative infinity, are called, this x equal a line is a vertical isotope. So let's play this game. They've given us the graph here. And it's always nice to look at a graph when I'm looking at vertical isotopes. I can tell if the function is going up to infinity or not, or I have some general idea. So I'm using the figure to determine the limits. So the A is look at x going to 1. I look at it from the left and the right. So here it is from the right. Here it is from the left. They're both shooting up to infinity. I'm good to go there. I'm looking at the limit of g of x as x goes to 3 from the left. So I pick up my left hand and I say, as I'm approaching 3 from the left, I'm going down to negative infinity. And as this one wants me to do, I'll just go ahead and do it from the right. Limit as x goes to 3 from the right of this g of x, I'm going to have to do it anyway, is as I go along this line from the right, I'm shooting up to positive infinity. I can see that the left and the right hand limit are going in different places, so this limit of just a plain 3 does not exist. However, I have vertical isotopes at both x equal 3 and at x equal 1. This next example, they want me to look at the limit as x goes to 0, this 5 plus x over x. And they have me looking at a table, and it appears that I'm approaching from the right, so I'm just going to put my little plus sign on here. And they're having us look at it numerically and then figure it out analytically. I see that what's going to happen is my numerator is getting closer and closer to 5. Notice that the numerator gets closer and closer to 5 as x gets smaller. So as x approaches 0, the numerator gets closer and closer to 5. The denominator gets smaller and smaller and gets closer and closer to 0. So I'm getting closer and closer to something that looks like 5 over 0, which means that this is going to shoot up to infinity. If my numerator had been getting, say, closer and closer, say if we had a numerator that was getting closer and closer to, say, some -2 or just any value, but a negative value, and the denominator was getting closer and closer to 0, then this thing would be shooting to negative infinity. They're just wanting you to kind of get the idea of this so that we can look at these problems analytically. I have the graphs at the bottom, but I don't want to use them until the very end. I kind of want to verify with the graphs. So let's try to get this one just purely analytically. As I get closer and closer to 3 from the right, that means I'm doing something like a 3.1 or 3.01 or 3.02, something that's a little greater than 3. As I do that, so anything, I'll write 3.01, 3.001, something of this sort. As I do that, this thing is going to -5 times some 3 plus, we'll call it, just something a little greater than 3. And this will be a 3 plus minus a 3. All I'm looking at are signs here. I know that this is going to shoot to one of the infinities, because if I put a 3 in here, there's no canceling. You know, I had a technique before that was canceling, and something canceled, I was good to go, but this doesn't cancel, so I know I'm going to have it shooting either up to positive infinity or negative infinity. So what I'm really concerned about are the signs. If this happens, this numerator is going to be a negative number, and the denominator is going to be it'll be a positive number. That lets me know that the limit as x goes to 3 from the right of this 2 minus 5x over x minus 3 is going to be going to negative infinity. And I'll look at my graph just to see, is it shooting down there to negative infinity as I go to 3 from the right? And it indeed is. So I can see that it's definitely doing that. Makes me happy. That was what I got. Let's look at this one. This one is I'm approaching 3 from the left, so that's some 2.8, 2.9, 2.99, something of that sort. Once again, I'm just concerning myself with signs, so I'll have 2 minus 5 times some less than 3, so we'll call it 2.9 or so, over a 2.9 minus 3. So let's see what kind of sign we get. I'm going to get still a negative in the numerator, and in this case I'll get a negative in the denominator as well, and a negative over a negative is a positive. So the limit as x goes to 3 from the left of this 2 minus 5x over x minus 3 is going to be positive infinity. And I'm checking here from the left as I take my left hand and I go follow this line. I am indeed going up to positive infinity, so that is verified. This next one, it'll make it easier if I factor this thing. So let me factor it. You don't have to factor, you could just kind of plug in values just and see what you get. X squared plus, oh no, that would be a minus, so hold. Minus 5x and then plus 6 all over, take out another negative x, and that would be x squared. Ooh, I can take out an x squared. And then that would leave me with just plain old plus 4. Perfect. Keep factoring. It just makes getting your signs a little bit easier. Minus x times chink, chink, chink. X minus 3, x minus 2. I see here nothing factors, so I can't just chunk in that 4. So we're going to be approaching 4 from the negative 4. That negative sign is hard to see in there. Negative 4 from the right. So I want to look at my picture last, but negative 4 from the right means something like negative 3.9, negative 3.99, negative 3.999, something in that. And I'm just going to look at signs at this point. So let's just say I plug in this negative 3.9. If I plug that in, this first term is a positive. This next term is negative 3.99 minus 3. That would be a negative. Negative 3.9 minus the 2, that's another negative. All over. A negative times a negative is going to be a positive, but then we're multiplying it by this negative. So that would be a negative. And then negative 3.9 plus 4, that would be a positive. Counting my number of negative signs, I have 3, that's odd. This is shooting down to negative infinity. I'm going to verify with my picture as I approach negative 4 from the right. This does indeed shoot down to negative infinity. I have a few graphs up here for you. We'll look at those in just a minute. We're going to find these limits analytically first. Of course, I want to factor this thing. Chink, 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 chink. That would be x minus 3, x minus 1, all over x plus 1, x minus 1. I see that this right here is going to cancel, chink, leaving me with x minus 3 over x plus 1. I can straight up plug in a 1 because of the canceling and say that the limit as x goes to 1 of this x minus 3 over x plus 1 is going to, just doing direct substitution because it is a rational function, 1 minus 3 over 1 plus 1 is negative 2 over 2. This is going to negative 1. I need to look at this on my graph and see what it's doing. You can see that I graphed this on my TI-84 calculator. The reason I did this was because in their section on in their text, they tell me that this is what a calculator looks like. This is what the old calculators used to do. If you have a TI-83, yours probably does look like this. But newer calculators don't do their algorithms in this fashion. What happens is the calculator does a numeric calculation. He goes tick, 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 and he calculates. He number crunches really fast, and he just connects the dots. So when he had a dot up here and he had a dot down here, he just connected those dots. Well, of course, that doesn't happen, and the calculator wasn't programmed to leave out this big long line. The newer calculators are, and you'll get a graph that looks something like this. If you were really going to draw this for me, what you would need to do is show that there was a vertical isotope in between here at -1, and then there was a hole. So this calculator graph still isn't as nice as it could be. It would be better if it showed me the hole there at -1. And notice as x approaches 1 from both the left and the right, what I have is a hole, and that is because that x minus 1 in the function itself canceled out. So they're going to have me look at the limit as x goes to -1 from the left, and I can look at as x approaches -1 from the left, I can look at it and tell you that it's going to positive infinity, but I'd like to be able to do it just straight up analytically by checking out the signs. So if I were to plug in a number, that means I'm plugging in a number, like I'm getting closer to -1, so it would be like, oh, let's say if I'm getting closer to that -1, that means I'm going like -1.1, -1.01, -1.001, something of that sort. So let's plug that in. I'm going to plug it into the easier function because the other part would cancel out anyway. So let's just plug in, say, a -1.1 and check out the signs. -1.1 minus 3 over -1.1 plus 1. Checking out the signs here, I would get a negative on top and I would get a negative on the bottom. That lets me know that this function is going to positive infinity. And that's what my graph looks like too. I'm glad it confirmed. Lucky for me. Cool. Let's go to the next one. As I'm going to -1 from the right, this means I'm looking at putting in numbers like -0.9, -0.99. I'm getting closer and closer to -1 from the right. So I'm just going to plug in, say, a -0.9. So -0.9 minus 3 over -0.9 plus 1. The numerator would be a negative. The denominator would be a positive. That tells me this thing is going to negative infinity. And my graph confirms that as well. In the previous section, we looked at these two limits of both sine and cosine, if you'll remember. And we proved that the limit as theta goes to 0 for cosine theta was 1, and the limit for sine theta equals 0. So I don't know really anything about cotangent, but I do know something about sine and cosine. So I'm going to rewrite this as the cosine theta over sine theta and try to figure out what that is, and then I'll confirm it by looking at my graph. I see that I'm going to have some value, like the cosine theta is going to 1 and the sine theta is going to 0. So I'm going to look at sines in this case because I know this is going to shoot up to either positive infinity or negative infinity. So I'm just going to look at sines. So if I'm approaching 0 from the right, that would be like 0.1, 0.01, 0.001, just trying to figure out as I'm getting there from the right, what is the cosine doing? The cosine in this case happens to be positive. And the sine in this case, as I'm approaching it from the right, if I think about my unit circle, from those positive numbers, the sine is also positive, which means that this thing is going up to positive infinity. So there he is from the right shooting up to positive infinity. I'm going to do the same game, but I'm going to do it from the left. In this case, I'm looking at negative 0.1 or negative 0.01, negative 0.001, something of that sort. So what are the cosine values doing at this point? The cosine values at this point are still positive. And then the sine values in this case, those y values from the unit circle, of that theta being negative down in this realm, those values are negative. So if you'll think about your unit circle and think the cosine right in here is a positive 1, doesn't matter which way you go, you're still on your cosine or the x's. Sine are the y's, so the y values on this right side are positive and on the left side would be negative. So this thing, the limit as theta goes to 0 from the left of this cotangent theta would then be equal to negative infinity, and that is confirmed with my graph. Let me know if you have any questions. Email me, or I'll see you at the Blackboard Collaborate.